Imagine stepping into a machine. It hums with energy. You punch in a date, any date, the year 2525, or maybe 3000 BC to see the pyramids being built. With a flash of light, you're whisked away to that very moment. Time travel. It's the stuff of dreams and science fiction, right? But what if it could be real? For centuries, humans have been captivated by the idea of time travel. The ability to witness historical events firsthand or journey to distant futures ignites our imaginations. But is time travel merely a fantasy, or could it be within the realm of scientific possibility? The answer, surprisingly, lies somewhere in between. While we may not have DeLoreans powered by plutonium just yet, the concept of time travel isn't as far-fetched as it sounds. In fact, it's rooted in the very fabric of our universe, woven into the laws of physics that govern our reality. Albert Einstein, perhaps the most famous physicist of all time, revolutionized our understanding of time. His theory of relativity, presented in the early 20th century, shattered our perception of time as a constant, unchanging entity. Einstein revealed that time is relative, fluid, and deeply intertwined with space. One of the mind-bending implications of Einstein's theory is time dilation. Time, it turns out, is not an absolute ticking away at the same rate for everyone, everywhere. Instead, the flow of time is affected by gravity and speed. The stronger the gravitational pull or the faster you travel, the slower time passes for you relative to someone in a weaker gravitational field or at rest. This isn't just theoretical mumbo-jumbo. Time dilation has been experimentally verified numerous times. Atomic clocks, accurate to within a fraction of a second over millennia, show subtle but measurable differences in timekeeping when subjected to varying gravitational forces or speeds. Believe it or not, astronauts aboard the International Space Station are experiencing time dilation right now, albeit on a minuscule scale. Because they're orbiting Earth at high speeds and in a weaker gravitational field than those of us on the ground, time moves slightly slower for them. Upon their return to Earth, astronauts are a tiny fraction of a second younger than they would have been had they stayed on Earth. While the time difference for astronauts is incredibly small, it demonstrates the reality of time dilation. If we could amplify these effects, achieving speeds closer to the speed of light, the time dilation would become much more significant. This is where the potential for future time travel truly lies. Section 4. The future of time travel. Some physicists theorize that traveling at speeds approaching the speed of light could allow us to journey into the future. As we approach this cosmic speed limit, time would slow down dramatically for us relative to those we left behind. A journey of a few years for us could equate to decades or even centuries on Earth. Another intriguing possibility involves black holes, regions of space-time where gravity is so intense that nothing, not even light, can escape. These cosmic behemoths warp space-time to an extreme degree, potentially creating pathways or shortcuts through the fabric of the universe itself. Some theoretical physicists speculate that black holes might act as portals, connecting different points in space-time. By navigating these cosmic maelstroms, we might be able to traverse vast distances instantaneously, potentially even traveling through time. However, the immense gravitational forces involved pose significant challenges, and our current understanding of black holes is still incomplete. Section 5. Paradoxes and possibilities. Traveling to the future, while mind-boggling, is one thing. But what about journeying to the past? This is where things get even more complicated and potentially paradoxical. The most famous of these paradoxes is the grandfather paradox. Imagine you build a time machine and travel back in time to meet your grandfather before your parents were born. Now, imagine something unfortunate happens, and you accidentally cause your grandfather's untimely demise. But if your grandfather died before your parent was born, then you would never have existed to travel back in time in the first place. This creates a logical contradiction, a paradox that throws the very fabric of causality into question. The grandfather paradox highlights the complexities and potential pitfalls of backward time travel. It suggests that altering the past, even in the slightest way, could have unforeseen and potentially catastrophic consequences for the present and future. While time travel to the past remains highly speculative, the possibility of traveling to the future, however distant, is grounded in the laws of physics as we understand them. As we continue to unlock the secrets of the universe, who knows what incredible breakthroughs await us. Perhaps one day, journeys through time will transition from the realm of science fiction to scientific reality.